It's an ear in the making produced on a 3D printer by researchers at Cornell University. It's designed to transform the lives of children born with microtia, a condition that leaves the external ear structure either deformed or missing altogether. Created with living cells, the artificial ear looks and behaves like the real thing. Plastic surgeon Jason Spector of Weill Cornell Medical Center says the printed ears have obvious aesthetic benefits for children afflicted by microtia, but they could also limit the need for the painful surgery required to help the child hear normally.
It is currently a very extremely challenging defect to reconstruct. Requires taking tissue from a young child. Usually the surgery is done about the age of 5 or 6. The sort of gold standard reconstruction is to use a child's own tissue, which means taking pieces of 3 of their ribs, which, as you can imagine, is quite painful. In addition to the pain that the child will suffer as a result of attempts to reconstruct the ear, the actual reconstruction that can be made really depends upon the artistic talents of the surgeon. And truthfully, this is such a complicated and really challenging surgery that there's maybe a handful of surgeons in the whole world who can make an acceptable facsimile of an ear.
That's where Dr. Larry Benasser comes in. Benasser and his biomedical engineering team at Cornell have been working with Spector to develop a better ear replacement. And with the printed ear, they think they've done it. The researchers produced the ear by harvesting living cells and suspending them in collagen, a principal protein in the body. After mixing the solution and dispensing it like ink into a 3D printer, the ear printing process could begin.
That's okay.
To achieve the precise ear shape, technicians used 3D panoramic photographs and laser scans capturing the geometry of the patient's other ear, and then fed the data into a computer that translated it into a lifelike implant.
The whole idea behind this is we simply don't want to put an artificial material in the body. That we want to replace ear cartilage that's absent or has been destroyed with new cartilage. And that's essentially what this tissue engineering technology does. And with time, our implants start out as cells suspended in a gel and turn into cells suspended in tissue, just like normal cartilage.
Although the printable ear hasn't been tested in humans, samples have been successfully implanted on the backs of laboratory rats. The biggest technical challenge, however, is generating the number of cells needed for the process. Just one implant requires 250 million cells.
One of the nice things about this technology is that it really doesn't care where the cells come from. We can mold or print cells of any type, whether they're ear cells or stem cells from whatever source. And there's the possibility of mixing them. We might be able to use just a few ear cartilage cells and stem cells and have the two populations communicate. So it's really unclear what will be the perfect population for the ultimate clinical use, but the technology that we've developed will be able to interface with whatever cell technology is seen in the future.
Tissue engineering is still a limited technology, but this research team says it's only a matter of time before the printing of new body parts has become straightforward, conventional medicine.